GLM 5.2 represents a monumental shift in the AI landscape. Developed by ZAI, this new model brings frontier-level performance to the open-source community. Released under the permissive MIT license, GLM 5.2 is designed to challenge proprietary models like Claude and ChatGPT, offering developers unrestricted access to high-end reasoning capabilities. This disruption democratizes access to state-of-the-art intelligence, ensuring that innovation is not locked behind closed APIs. Let's see what makes this model a true industry disruptor. On June 12, 2026, the United States issued a sweeping export control directive. This regulation mandated an immediate suspension of access to top-tier AI models for specific international regions. This directive acted as a digital barrier, severing the link between premier US-based AI providers and global partners. Consequently, key platforms like those managed by Anthropic were forced to restrict their API access. The sudden withdrawal created an unprecedented vacuum in the global AI market. Organizations that relied on these sophisticated architectures found themselves without their primary tools for innovation. This market displacement did not just leave in void, it signaled the start of a massive shift in how the world approaches artificial intelligence. In the heart of Beijing, a new player has emerged in the global AI landscape, ZAI. Born out of the need for rapid technological advancement, ZAI has quickly positioned itself as a focal point for domestic innovation. Facing increasingly stringent U.S. export directives, the local industry encountered significant obstacles. These restrictions were designed to limit access to high-end processing hardware and cutting-edge software ecosystems. ZAI's release of GLM 5.2 served as a definitive statement. It was not merely a software update, it was a technological and geopolitical milestone, demonstrating resilience and capacity under pressure. GLM 5.2 stands out due to its sophisticated mixture of experts architecture, containing a massive 744 billion total parameters. Unlike standard models, the mixture of experts approach uses a router to activate only a specific subset of these parameters for any given task. This allows GLM 5.2 to harness the immense intelligence of 744 billion parameters while maintaining the computational efficiency of a much smaller model. A defining feature of GLM 5.2 is its massive 1 million token context window. This capacity allows the model to ingest and reason over entire libraries of books or extensive codebases in one go. By reading this volume of information simultaneously, the model can maintain coherence across complex project structures, finding patterns that shorter windows would miss entirely. This enables developers to upload entire documentation sets, massive repositories, or hundreds of legal documents, resulting in unprecedented levels of information retrieval and synthesis. GLM 5.2 introduces dual reasoning modes designed to match the computational intensity with your specific task requirements. High mode minimizes the step count for immediate output, while max mode initiates a deep, recursive chain of thought that explores multiple solution paths. Users can dynamically toggle these modes via the API or platform settings to balance between speed and precision. GLM 5.2 is not just a leap in performance, but a massive economic shift. By optimizing the architecture, we achieve a cost structure that is 5 to 7 times more efficient than current industry benchmarks. With input costs as low as $1.40 and output costs at $4.40, developers can scale applications at a fraction of the cost previously required. This economic advantage empowers a new generation of AI-driven tools, lowering the barrier to entry for complex, token-intensive workflows. Proprietary models are often treated as black boxes. They keep their architecture hidden and require recurring monthly fees for access, limiting your control and portability. GLM 5.2 shifts this paradigm. By releasing open-source weights under the MIT license, it allows you to run the model locally on your own hardware. This transition removes vendor lock-in, ensures data privacy, and empowers developers to integrate high-performance intelligence directly into their own stacks without external dependencies. GLM 5.2 has officially taken the #1 spot on the Design Arena benchmark, proving its capability in modern web development. By outperforming industry leaders like Claude and Tailwind CSS implementation, GLM 5.2 produces cleaner, production-ready code. Beyond simple syntax, the model demonstrates a deep understanding of complex layout structures and visual hierarchy, ensuring designs are not only functional, but visually balanced. This victory marks a significant shift in how AI models handle front-end engineering tasks. Software engineering benchmarks, or SWE bench, represent the gold standard for testing an AI's ability to resolve real-world issues on GitHub. It is a true test of coding autonomy. In the latest SWE Bench Pro evaluations, GLM 5.2 achieved a score of 62.1, successfully surpassing the 56.0 score attained by GPT 5.5. Surpassing competitive models in this domain indicates a significant leap in reliable autonomous code generation, directly impacting how efficiently we can maintain and build enterprise-grade software. GLM 5.2 demonstrates remarkable capabilities in high-level reasoning, particularly in competitive mathematics. On the rigorous AIME 2026 examination, it demonstrates performance competitive with the most advanced frontier models available today. This chart illustrates the percentage of problems correctly solved. As shown, GLM 5.2 achieves a leading score, proving its architecture is not just efficient, but exceptionally capable at complex logical synthesis. By mastering competition-level problems, GLM 5.2 bridges the gap between general language understanding and specialized mathematical reasoning. Standard transformer models often redundantly process key and value pairs, leading to massive memory and compute waste. Index Share solves this by creating a global index that shares key value caches across tokens, eliminating redundant computations while maintaining output fidelity. The result is a significant reduction in flops, drastically lowering the cost per inference without sacrificing performance. GLM 5.2 introduces an upgraded multi-context processor, or MCP layer, enabling faster generation through speculative decoding. Instead of generating one token at a time, a lightweight draft model predicts a short sequence. The main GLM 5.2 model then verifies these tokens in a single parallel pass. This approach drastically reduces latency, resulting in a 20% increase in overall output speed compared to traditional autoregressive generation. A defining milestone for GLM 5.2 is its training foundation. Unlike models reliant on imported US silicon, GLM 5.2 was trained entirely on Huawei Ascend hardware. This marks a critical shift in AI development. By bypassing dependency on traditional hardware providers, this model demonstrates that frontier capability can be achieved through alternative, self-reliant infrastructure. The scalability of the Ascend platform allows for the massive matrix multiplications required by large language models. Proving this architecture works at the frontier level, effectively decoupling AI progress from external supply chain constraints. This independence is more than a technical achievement. It represents a significant strategic step toward autonomous AI evolution, ensuring long-term access and control over compute resources. June 2026 marked a period of rapid transformation in the artificial intelligence sector. We witnessed three major industry shifts. First, the industry saw the official retirement of GPT 5.2 as infrastructure resources shifted to next-gen models. Second, the rise of Claude Opus 4.8 established a new high watermark for complex multimodal reasoning capabilities. Finally, Google introduced Gemini 3.5 Flash, prioritizing extreme low-latency performance for real-time enterprise applications. These releases underscore a broader market transition towards specialization and model efficiency. The era of relying on a single model is fading. Modern architecture now favors a multi-model strategy, where an intelligent router directs tasks to the most cost-effective and capable model for the job. Complex coding challenges are routed to Claude. Specialized agentic workflows are directed to GPT, while massive bulk data processing is handled efficiently by the GLM 5.2 engine. This approach ensures developers maximize accuracy while optimizing for operational costs and latency. You can access GLM 5.2 primarily through the Z.AI official platform. Simply generate your API key in the developer console to start integrating. For broader integration, GLM 5.2 is also available on third-party aggregators like OpenRouter, which allows you to switch between models seamlessly. Here is a sample API request. You point your request to the endpoint, specify the model ID as GLM 5-2, and pass your prompt within the payload. Deploying GLM 5.2 locally allows for private, low-latency AI performance. While standard full-precision inference requires substantial hardware, we can optimize significantly. By utilizing 2-bit GUF quantization, we drastically reduce the memory footprint. This process compresses parameters while maintaining high semantic integrity. Unsloth AI provides optimized kernels that reduce overhead by up to 40%. This workflow enables running high-performance models on standard desktop hardware. GLM 5.2 excels in 3 primary developer workflows. First, its massive context window allows for deep analysis of complex, multi-file codebases. Second, it serves as a powerful engine for rapid UI prototyping, translating sketches and descriptions into functional front-end code instantly. Finally, it is ideal for cost-sensitive back-end workflows, providing high reasoning capabilities while maintaining operational efficiency. Leveraging these use cases allows teams to maximize the performance of GLM 5.2 across their entire tech stack. The democratization of frontier-class AI changes the landscape for developers globally. By providing free and open access, we eliminate the high entry barriers that previously limited innovation to only well-funded regions. Developers in under-resourced regions gain the ability to build sophisticated tools without prohibitive costs. This shift empowers a new wave of local problem solvers to build solutions tailored to their unique community needs. True innovation happens everywhere. When high-performance intelligence is universally accessible, we foster a more equitable global ecosystem where the next breakthrough can emerge from anywhere on Earth. The AI landscape is undergoing a massive shift. Historically, businesses relied on monthly subscription models, paying per-token fees for cloud-based inference. Now, we are moving toward infrastructure-based ownership. Companies are integrating open-weights models like GLM 5.2 into their own stacks, eliminating per-token overhead. By owning the infrastructure, businesses turn variable usage costs into a fixed asset. This provides scalability and long-term cost predictability for mission-critical operations. The next horizon of the AI arms race is defined by the upcoming launches of major industry models. We anticipate the releases of GPT 5.6 and Gemini 3.5 Pro to set new performance milestones. As competition intensifies between closed-source proprietary systems and rapidly evolving open-source models, the primary beneficiary is the developer. Competitive pressure is consistently driving down API and inference costs. This dynamic tension acts as a catalyst for innovation. Whether through proprietary scaling or open-weight democratized access, the landscape is shifting toward extreme efficiency and ubiquity. As we conclude, remember that the AI landscape is shifting rapidly. Success for builders now relies on 3 core principles. Stay curious as benchmarks evolve. Adopt multi-model routing to balance cost and capability, and always keep an eye on open-source alternatives to maintain your competitive edge. Building effectively means decoupling your application from a single provider. Use routers to direct tasks to the most efficient model, whether proprietary or open source. The tools are evolving, but your agility remains your greatest advantage. Keep building, keep testing, and stay ahead of the curve.